I'm Nanda, and in today's video we are going to discuss about series resistance and parallel resistance. Hello all. In this section we are going to study about a series resistance circuit which is connected to a DC voltage supply. Okay, as you can see, I have given a voltage V and three resistances are connected in series. How to connect three resistors in series? That is, the end of one resistor is connected to the beginning of next and the end of the next resistor to the beginning of the third one. So this is how resistors are connected in series. The peculiarity of a series circuit is that current flowing through all the resistors will be the same. Then what changes? The changing factor is the voltage here. Okay. Now we know according to Ohm's law, I is directly proportional to V, or you can say V by I is equal to R. So from this you can calculate values of V1, V2 and V3. V is equal to I into R. Then what is V1? V1 is equal to I into R1. V2 is equal to I into R2. V3 is equal to I into R3. Okay. So sum of these three voltages, that is V1 plus V2 plus V3, will be equal to what? IR1 plus IR2 plus IR3. If you take I as a common value, I into R1 plus R2 plus R3. Okay. Here V1 plus V2 plus V3 is equal to I into R1 plus R2 plus R3. Isn't it? So V1 plus V2 plus V3 will be equal to what? V. So V is equal to I into R1. If you are bringing this I here, what happens? V by I is equal to R1 plus R2 plus R3. What is V by I? V by I is the effective resistance of a series circuit. R is equal to R1 plus R2 plus R3, where R is known as the effective resistance of a series circuit. Okay, so this is the required equation. Now if they are asking three resistors, say 2 ohm, 5 ohm and 10 ohm are connected in series, calculate their effective resistance. So there is no need of deriving all these formulas. You can directly substitute in this equation where R is equal to 2 plus 5 plus 10, which is equal to 17 ohm. Okay. That's all about a series resistance circuit. So this is a parallel circuit with resistances. Here you can see three resistors R1, R2 and R3 connected in parallel. How are they connected in parallel? That is, the starting end of all the resistors are connected to the same point and the finishing end of all the resistors are connected to the same point. Clear? Now, let I be the current flowing through the circuit and let V be the voltage. Peculiarity of a parallel circuit is that the voltage flowing through all the resistors will be the same, but current varies from resistor to resistors. Clear? According to Ohm's law, we have current I is directly proportional to voltage, or V is equal to I into R. So I is equal to V by R. By using this equation, we can calculate I1, which is flowing through R1, I2 flowing through R2 and I3 flowing through R3. So we can find these three. How to find I1? We know I is equal to V by R. Then what about I1? I1 is equal to V by R1. I2 is equal to V by R2. I3 is equal to V by R3. Here I am introducing another term, that is G. G is known as the conductance. Actually, G is equal to 1 by R, where G is known as the conductance of the circuit. Clear? So, instead of V by R1, you can write V into G1. V by R2, V into G2. V by R3, V into G3. Now, the total current can be calculated using the equation I is equal to I1 plus I2 plus I3. Isn't it? So, substituting the values for I1, I2 and I3, V by R1 plus V by R2 plus V by R3. I is equal to, V can be taken as common. So, I is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. If you bring this V here, what happens? I by V is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Or you can write I by V എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താണ്? What is I by V? I by V is equal to 1 by R. V by I is equal to R. So, I by V is equal to 1 by R, which is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, this is the required resistance of a parallel circuit. Clear? Now, if there are only two resistances, say R1 and R2. Let R1 and R2 be the two resistances which are connected in parallel. Then easily you can find the effective resistance, that is R is equal to R1 into R2 divided by R1 plus R2. So, if there are only two resistors, you can calculate the effective resistance, parallel resistance, using this formula. Now, let us go with an example. Okay. So, I am taking, let R1 is equal to 2 ohm. R1 is equal to 2 ohm. R2 is equal to 1 ohm. R3 is equal to 4 ohm. How to calculate the effective resistance R1, effective resistance of R1, R2 and R3 can be calculated using the formula 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3, which is equal to 1 by 2 plus 1 by 1 plus 1 by 4. Okay. Now, the effective resistance will be 1 by 2 plus 1 by 4, which is equal to 3 by 4. 3 by 4 plus 1. Okay. So, how to calculate 3 plus 4 by 4? 7 by 4. This is 1 by R. Okay. So, what is effective resistance R? R is equal to 4 by 7 ohm. Clear? So, if 3 resistors, similarly you can calculate for any values of resistance. So, that's all about a parallel DC circuit. And if you like this video, please like, share and subscribe. Thank you.